Right, we're now looking at question number 5 of the review, where the diagram has shown us a picture of the graph, and you can see that the graph has been given as standard form, so it must be then that this a value is equal to something negative, right? Because the parabola is facing downwards, it's negatives, it looks like a sad face. The line x equals 2 has been given as the axis of symmetry, and m looks like it's the y-intercept, and n looks like it's the vertex, which in this case is a maximum because it's a downwards facing parabola. Alright, part A says let's find the value of a. We need to find this value right here. Well, it doesn't look like there's really a lot that we can do with this problem, but let's just look at the given information. We've got no information, no information, no information, no information. Here's our information. What do we know about an axis of symmetry? Well, there's 3 different equations we know. The first one is that if the equation is given in standard form, it's negative b over 2a. If we know the 2 roots p and q, that is to say the 2 x-intercepts, then it's the midpoint between p and q. And if it's been given in vertex form, then x is equal to h, the x-coordinate of the vertex. The form that we have in this situation is, of course, the first one, so we're going to use this first formula. We know that x is equal to 2 at that axis of symmetry. Our b value we can see has been given as positive 4. We want to take negative b over 2a, and a is the thing that we're trying to find. Let's multiply both sides of the equation by 2a by bringing it up to the left. And so if I multiply both sides by 2a, I get 4 is equal to negative 4, and we'll divide both sides by negative 4 in order to isolate that a is equal to negative 1. Then in part B it says let's find the coordinates of m and n. M is easy to find because we can see that negative 3, the constant value in our original standard form equation, always represents the y-intercept. So m says the coordinates, so read the question carefully. We know that when x is 0 at a y-intercept, our corresponding y value is negative 3. Then it asks for the coordinates of n. So let's put down the new function, right? We know that the a value is equal to negative 1, so negative 1x squared plus 4x minus 3. Well, maybe the best way for me to find the coordinates of n, or the safest way, I suppose I've got a couple of options, don't I? I know that the x-coordinate at this vertex, due to the axis of symmetry, is 2 comma something, right? Because the axis of symmetry has got all of the points whose x-coordinates are all equal to 2. So if I just typed the x equals 2 into this function right here, well then it should give me the corresponding y-coordinate, and then I would have the coordinates of n, the vertex. So I'm doing the negative of 2 squared plus 4 times 2 minus 3, gives me negative 4 plus 8 minus 3, which gives me a value of 1. And so the coordinates of n then must be when x is equal to 2, y is equal to 1. Question number 6. Let's factorize the expression. Obviously it's not a trinomial, and it doesn't look like a difference of squares either, because kx is not a perfect square. But before I even imagine those two things, I should think about a common factor. Here I can see there's a common factor of x. X is multiplying first an x in order to get the x squared term, and then it's multiplying a negative k, if you imagine it distributing, in order to get the negative kx term. So there's the factorization. Hence, solve the equation x squared minus kx equals 0. Does this look familiar? Of course, we just dealt with it. So why don't we replace the x squared minus kx? When it says hence, it expects you to use what you just did. And so let's replace the x squared minus kx with the x times x minus k, the factored version. And this is the zero product property. Either x is equal to 0, or the other factor that is being multiplied, in brackets x minus k, is equal to 0. So x equals 0, or x minus k equal to 0, and that yields the solutions x equals 0 and x equals k. Now the diagram shows this particular function Remember, look at this, x squared minus kx. It's the same function. So we're not changing the question at all. We're now looking at simply a picture of what x squared minus kx is equal to. Now if we said x squared minus kx is equal to 0, meaning that this thing is 0, x squared minus kx equals 0, we discovered that our two solutions were x equals 0 and x equals k. Look, here's the x equals 0, and here's the x equals k. That must mean then that k is equal to 3. And part D, what is the minimum value of this function? Well, we know that the minimum value must occur at exactly the midpoint. So then we should be able to take this value of 1.5. I know it's 1.5 because 0 plus 3 over 2 is the midpoint of the two x-intercepts. That gives me 1.5. And so if that's the x value at the vertex, how can I find the corresponding y value? Well, I could just plug it now into my equation. You remember that we now know that the value of k is equal to 3. So let's substitute that. And now let's put in that x value at the vertex of 1.5, and 1.5 squared minus 3 times 1.5. Here we go, 1.5 squared minus 3 times 1.5 gives me a value of negative 2.25. So what is the minimum value? That is to say the y value, right? Value means the y value. The minimum value is negative 2.25. That is the only answer that they're looking for. You don't need to give the coordinates of the point. Another way you could have found that minimum value, meaning the minimum y value, would have been to type in our function into our y equals and then look for the minimum using graphical methods on your calculator. So we're now dealing with the function. Once we've solved for the value of k, x squared minus 3x. So we've got x squared minus 3x. We want to look for the minimum, so when we graph it, whoops, how do I get rid of the second? I don't really know. Let's find out. No, it's not what I wanted. Oh, I just did it again, didn't I? There's the graph. I want the minimum value, so I'll say second trace to go into the calculate menu. Option 3 is the minimum. And so it says the left bound, that means the cursor should be safely flashing on the left of the minimum, and then the cursor should be flashing on the right of the minimum, I don't know, maybe at 3, and then we want to guess, I don't know, maybe it happens at 2, in fact it happens at 1.5000009, you can interpret that, that means of course x equals 1.5, but we're interested in the minimum value, right, the y value, and that's going to be negative 2.25. Moving on to question number 7. Now then, you'll notice that I've already reorganized my sheet. I got rid of the old number c, which asked for the average value, and I've replaced, well, I didn't replace it with anything. I've just made my old part D equal to a new part C. As we got rid of the old part C, the D moved up. Alright, part A. Let's state the amount of energy held by the battery immediately before it was used. Before it was used, this means that no time has passed. And so if t was equal to 0, this term will disappear, this term will disappear, and the total amount of energy will be, when t is equal to 0, we're going to have 25 will be the initial amount of energy. How much energy will be available after 20 minutes? Alright, so I'm going to have to substitute 20 into the function. Look, you can get a method mark just by showing that substitution, so it is worth writing down so that you're explaining to the examiner, or in this case me, what your thought process is. The substitution step IB loves to see, so please don't look for don't miss an opportunity to show that substitution, especially with parentheses. But at this stage I would probably go to the calculator. So we'll say then, what is 0. In fact, what I'm going to do is I'm going to put this into my y equals, and then I'm going to look for the value of y when x is 20. You'll see what I mean in a minute. So I'm doing 0.003, and then instead instead of a 20, I'm just going to leave it as an x, and I'll substitute my x to be 20 a little bit later on. So that's an x squared minus 0.625 times x plus 25. Alright, I want to find out what is the value, so second trace, what is the value of this function, the amount of energy, oh shoot, it's not what I meant to do, sorry, let's start again. Or maybe it is what I meant to do, I just didn't expect that to happen. What is the value when x is equal to 20? Now it doesn't appear, yeah, I was afraid of this. We've got to adjust the window so we can see the action going on. And it might take quite a little bit of work in order to adjust the window. I'm now regretting this strategy. It looks like it would have been better just for me to have gone straight away with typing all of this into the calculator. 0.003 20 squared minus 0.625 times 20 plus 25. And we get our y value of 13.7. But the reason I was trying to do it this other way, and I will finish it off, if I go into my window and I adjust my x max to say something like 30, and I adjust my y max to something like 50, let's see if I can see it now on my graph. Yeah, there's my parabola. Whoops, it looks like I can't quite see the minimum yet, so I'm going to increase the x value to say something like 100. Let's see if that's enough to be able to see the minimum. And we'll graph it again. And boy, I can almost see the minimum. Let's try my x max going out to say 200 then, and see whether then I can see my minimum. So there's my graph. Fantastic. Now I can see all of the action going on. Perhaps now I can show you my original idea of going into the value, and I want to type in what is my y value when I have an x value of 20 minutes, and it shows you that the corresponding y value is 13.7. It even shows you the location on the graph. You just have to have that part of the graph in the window for it to work. Part C says, how many minutes will it take for the energy to reach 0? That is to say that we're looking for when is the energy, the y value, when does it reach 0? Well, in other words, it's looking for the first x-intercept. That's going to be the first place that the energy hits 0. So we'll say then, second trace to go to the calculate 0 option. What's the left bound? Yes, the cursor is safely flashing on the left. Let's bring the cursor over to the right at the 0 that I'm looking for. A little further just to be sure. There it is. And then let's take a guess pretty close to the x-intercept. Shows us that it occurs when x is equal to 53.99. I think you have to interpret this, especially when you round to 3 significant figures. Of course, it's t instead of x, isn't it? We're looking at the time. Time is going to be 54 minutes when you round to 3 significant figures. Another way you could have done this problem is to think, okay, look, if my energy is becoming 0, so we're now dealing with the equation 0 equals 0.003 20 squared. Oh, sorry, it's not a 20 anymore, is it? We're now dealing back with our t. So 0.003 t squared, we're going to substitute that with an x in a minute, minus 0.625 t plus 25. Remember that t will be changed for an x. I could put this into polysimilt. So we'll go apps, polysimilt, and I'll go with my poly root finder. Poly root finder only works when you've got a 0 on one side, as we do right now. So option 1 for our poly root finder, we're a second degree equation, and I'm changing my coefficients to be 0.003 and negative 0.625 and 25. Let's see the solution, and it tells, well, it's given it as fractions, so I'll press this button to change it from fractions into decimals, and it gives me two solutions, 154.3 and 53.99, which we said is 54. I'm thinking that in this question, they probably mean you just to find that first one, because surely that is the time when we first reach 0. I suppose if you were a little paranoid, and I don't blame you, maybe you also include 154 as another place where the energy has reached 0, although of course this time it's now on the increase. And then question number 8. The profit in Swiss francs is given by this quadratic function. So part A, we need to you guys would need to copy and complete the table onto your separate line sheet of paper for one of these long style questions. One clever way of doing this problem would be to would be to put in this equation into my y equals. So I've got negative 1 over 20 x squared plus 5x minus 30. The reason that this is clever is because I've got an option on my calculator called table, where now I can scroll down my table and find all of these values. So what am I at when x is 0? Well, my y value is at negative 30. What happens when x is 10? Scrolling down, I can see that when x is 10, my y value is 15. Of course, this was already given to me. It's a little tedious to scroll down by 10 at a time, so why don't I go to Table Set? That's in second window. And you'll see that right now my change, that delta symbol, means the change in the table is always every 1 unit. So why don't we start at 10? My table start is at 10. This time I'm going to go up by increments of 10. Now let's say second graph to look at the table and look at all the values I can fill in. When it's 10, it's 15. When it's 20, we're at 50. When we're at 30, we're at 75. When we're at 40, we're at 90, that was given. When we're at 50, we're at 95. When we're at 60, we start going down again, don't we? We're at 90. And by the time we get down to an x value of 90, it looks like our y value has become 15. You might notice the symmetry around that maximum of 95. 90, 90, 75, 75, 50, 50, 15, 15, and so forth. Alright, it says on graph paper we should draw axes for x and p. Sorry, I don't have graph paper handy right now, so I'm just going to do a very rough sketch, but you guys, when it says graph, you guys should really, on graph paper, you've got to be very accurate. So I'm going to draw my x and my p axes. So of course x is horizontal, p is vertical, and I'm starting at negative 30. And by the time I've gotten out to a value of 50, so that's 20, 40, 60, 70, 80, 90. By the time I've reached 50, I'm at a maximum value of 95. And so I'm rising. So I'm looking something like this. That's pretty rough, isn't it? But when I hit 90, I'm still at, say, 15. Same as I was when I hit 10. When you're using suitable scales, it says, I would probably use a full centimeter for each 10 units in the x direction and the y direction, and just fill that graph paper up with a nice big graph. Okay? Alright, we need to use our graph to find the maximum possible profit. Well, the maximum profit, right, P is on the y-axis, the profit reaches a maximum at 95. And so there's our maximum. Maximum possible profit then must be 95. What's the unit? Are we in dollars? In Swiss francs. Okay, so we're dealing with a maximum possible profit of 95 Swiss francs. Part I, the number of glasses that need to be sold to make the maximum profit. We can see that that occurs. 50 glasses will be required. Part I, the number of glasses needed to be sold to make a profit of 80 Swiss francs. Now if I look at my table, I never make a profit of 80. So let's go back to our function. We're really trying to find out where is this function equal to 80. One way we could have done this then is, having entered it already into y equals, we could make the y1 the left-hand side, and the right-hand side could be 80. And we could find out then where these two graphs intersect. Oh dear, I haven't set my window very well, have I? So it looks like we need to see more stuff in the y direction. So in my window, let's increase my y maxed to something like, say, 300. Hopefully that will be more than enough. Alright, there's the parabola. And let's also, and there's 80. So where is our function equal to 80? We can look for the intersection between these two graphs. So the first curve is, yes, y1, that's the left-hand side of the equation. The right-hand side is 80. And let's guess. It wants to know which of the two intersection points you want to find. I'm going to guess that they intersect at around 30. Tells me that, in fact, the intersection occurs at 32.679. Now, let's round this to the nearest integer. That gives us 33 glasses, because you can't have a fractional number of glasses. So the number of glasses then will be 33. And there's another way that we can have exactly 80. Again, let's find the other intersection point. Second calc intersect. What's the first curve? Yes. What's the second curve? Yes. And now we need to come up with another guess. I'm guessing that it happens at around 65. In fact, it happens when x is equal to 67.3. Again, of course, we cannot have a fractional number of glasses. So 67 is the nearest integer number of glasses. So we make a profit of 80 Swiss francs. Another way you could have done this problem would have been to move everything over to the same side of the function. So we've got negative 120x squared plus 5x. And if we move the positive 80 to the left, it becomes a negative 80. Combined with that negative 30 gives me negative 110. If we entered this function, and of course, what am I left with? It is now equal to 0 on the right, yeah? When you see a 0, this is an opportunity to use apps, polysimilt, and the polyroot finder. So I'm going to put in then in my polyroot finder of order 2. Next, I'll put in my a value as negative 1 over 20. That's the coefficient of the x squared term. The coefficient of the x term is positive 5. And the coefficient at the end is negative 110. And it will give me my two solutions when I say solve of 67.3, 32.7, which we know that because it represents a number of glasses, we have to round it to the nearest integer, so the answers make sense. Oops. Alright, nearly done. Part 4. The amount of money initially invested by the three students. Initially means that time passed is 0. And we can see from our graph that when the time passed is 0, we've got a profit of negative 30, which must mean that they originally invested 30 Swiss francs. That's why at the very beginning they were 30 Swiss francs below. And part D, they share the profits in the ratio of 1 to 2 to 3. If you imagine 1 to 2 to 3, that's a total, that is to say that for every 6 parts of the profit, there's somebody, this is Balliot, she gets only 1 of those parts, Jane gets 2 of those parts, Fiona gets 3 of those parts, maybe because they've invested different amounts of money. Perhaps Balliot only invested 5 Swiss francs at the beginning, Jane invested 10, double the number, and Fiona invested 15, triple the number. Now let's suppose they sold 40 glasses of lemonade, that is to say that they earned a total of a profit of 90 Swiss francs. How would we show that in a ratio of 1 to 2 to 3? Well, let's divide our 90 Swiss francs into 6 parts, because we know that Baljeet will only get 1 of those 6 parts, Jane will get 2 parts, Fiona will get 3 parts. We divide it into 6 equal parts. Each part will be 15. So that must mean that Baljeet got 15, Jane got 15 plus 15, that's 30, and Fiona got 15, 15, and 15, and she's the one that we're being asked for. What's her share of the profits? 45 Swiss francs. Alright, good luck studying for your quiz.